Above you, the Milky Way arches like a river of frost. You know this sky even if you've never seen it at its darkest, the band of light, the familiar constellations, the slow wander of planets. It feels permanent, like a picture framed by time. But it is not. Every star is moving. The entire galaxy is drifting. And far across a gulf so large we measure it in light itself, another spiral galaxy is drawing nearer, almost imperceptibly, as if the universe were taking a very long inhale. That neighbor is Andromeda. Right now, it's a dim smear to the naked eye on clear, dark nights, a pale almond of light, 2.5 million light-years away. Its light began the journey before our earliest ancestors shaped stones. You can find it if you know where to look. A soft patch in the velvet, old as myth. But Andromeda is not only a thing to find, it is a thing heading our way. This is a story about what happens when two great star cities meet. Not with a crash, but with a slow embrace so vast and gentle that individual stars almost never touch. Instead, their invisible halos of dark matter interlace, their tides pull, their gas clouds compress, and their shapes change. It takes billions of years. The universe is patient. And yet, if you had the chance to stand under that far future sky, if you could watch over a lifetime stretched to match the rhythm of galaxies, you would witness a series of nights that begin familiar and end in a beauty we can only describe with breath and metaphor. The sky would fill, widen, ripple, and settle into something new. We even have a name for it. Milkomeda, the eventual descendant of the Milky Way and Andromeda entwined. Imagine beginning with this simple question. What will the night look like? Not the mathematics, not the full machinery of gravity, just the texture of the darkness. Where will the band of the Milky Way go? What shapes will rise at dusk? When will two cores share the same sky like twin lanterns? When the dance is done, will there still be a river overhead, or will there be a luminous sea? We'll move gently through time. First, the approach, when Andromeda grows from a faint patch to a great, wide arc. Then, the first pass, when streams unfurl and the night acquires long, gauzy ribbons of new light. After that, a long interlude as the galaxies swing past and return, their cores spiraling inward, their dust kindled into starbirth. Finally, the merge and the afterglow, the time when the sky becomes the sky of Milkomeda, different but not less beautiful. Along the way, we'll listen to the slow heartbeat of gravity, and we'll let imagination and evidence walk together. If you're wondering whether this means danger, breathe. Between stars, there is mostly emptiness. Even when galaxies cross, the odds of two suns colliding are so small they can be whispered. The transformation is grand, but the chain of nights beneath, it remains gentle. In fact, some worlds will see a sky brighter and more textured than ours, rich with star clouds and arcs that look like brushstrokes pulled across dark silk. The universe tells this story in whispers we can measure, and in shapes we can simulate. Astronomers have watched Andromeda's motion carefully, measured its slight drift against the pattern of more distant galaxies, and found that it is indeed coming with a speed that sounds quick to us, but is slow for the cosmos. From the local group of galaxies, gravity makes little islands that float, even as space elsewhere is carried outward by expansion. Our island is about to change shores. So, begin again with a quiet night. Picture Andromeda as you might see it in a future, 1 billion years from now. Larger, clearer, like a pale sunrise frozen in the north. Picture its fuzzy oval taking on texture, hints of spiral arms, knots of star clusters. The sky stays familiar, but there is a new guest who refuses to leave. It rises earlier in the evening. It stretches a few degrees wider with each epoch. It is beautiful, and it will keep growing. And now the soft cliff. Someday, not so long by the universe's measure, Andromeda will not be a separate thing in the sky. It will be an entire presence, a curved continent of light. The Milky Way will no longer be a single river of stars, but a sea mixing with another sea. What does that look like from a warm hillside under a changed sun? Sit with that image for a beat. Feel the night widen. We'll come closer, one breath at a time. Let's lean into the quiet facts, as if we were tracing a finger across a star map. We live in a small family called the local group, dozens of dwarf galaxies and a few grand ones, with the Milky Way and Andromeda the largest. At this scale, the usual stretching of space, the Hubble flow, is overwhelmed by their mutual gravity. Each galaxy isn't just stars and gas. It's wrapped in a much larger halo of dark matter, an invisible mass that gives galaxies their grip. Those halos are moving toward each other like two drifting fogs, overlapping long before the bright spirals meet. We didn't always know what Andromeda was, or that it was coming. For centuries, it was the little cloud, a faint nebulous object catalogued by skywatchers like the Persian astronomer Al-Sufi 1,000 years ago. Through small telescopes, it looked smeared, like breath on glass. Only in the early 20th century did Edwin Hubble, standing on Mount Wilson with a telescope that pulled faint light out of the background, resolve tiny, pulsing stars inside that blur. These were Cepheid variables, stars whose rhythms reveal their distances. Hubble measured and found Andromeda to be far beyond the Milky Way. Not a cloud within our galaxy, but a galaxy of its own, a city of stars across the void. The universe suddenly grew. The next step was motion. Is Andromeda passing by or heading toward us? For a long time, all we had was its radial velocity, a part of its motion that comes toward or away from us, measured by how its light is shifted. Andromeda's spectrum is blue shifted. Its light waves are compressed, like ripples pushed together by a moving mote. That means approach. But how fast? And at what angle? The full answer required watching Andromeda creep against the background of even more distant galaxies, like a ship crossing a far horizon. This is subtle work, done with space telescopes that don't blink. In 2012, astronomers using the Hubble Space Telescope measured Andromeda's sideways drift and found it to be small. The vector, when combined with the pull of the two dark matter halos, points to a future meeting, a gentle, inevitability-shaped word that means they will coalesce. Now breathe out and imagine standing on a shore of time. 1 billion years from now, the sun will be warmer, its light a little whiter, its edges subtly changed. Earth, if it still has oceans, will glimmer differently. But the sky, what would it display? Andromeda would be larger than the width of Orion. You'll be able to pick out structure with your naked eyes under a dark sky. Not just a glow, but hints of curves and lanes, soft roads of dust, star clusters as tiny peppered grains of brightness. Andromeda's core would be a bright almond, glowing with ancient, tightly packed stars. The night would have a new, slow pulse, an object whose size changes not over minutes or years, but over many lifetimes. As Andromeda grows, the Milky Way above you is still the river, you know, even if the constellations have drifted. The Big Dipper pours from a different angle. Scorpius arches slightly closer to the horizon. Stars live and die, and proper motion redraws the patterns. But the band is still there. As the galaxies drift together, they also tug on each other's farthest stars, stretching faint streams like taffy. In very dark, very clear conditions, from a high plane perhaps, with the winds hushed like a blanket, you might begin to catch ghostly extensions near Andromeda's outskirts, tidal features so faint that only the deepest telescopes now can show them. To a future naked eye, under skies free of light, those features might become subtle brush marks in the night. Consider Triangulum, the third largest member of our local family. And 33 is smaller, a blue-leaning spiral that hums with starbirth. It sits near Andromeda on the sky even now, a small whirl. Simulations suggest Triangulum is part of the Andromeda subgroup and may join the dance, perhaps arriving first, perhaps spiraling around and then feeding the final embrace later. Its role adds detail to the sky, like a third hand in a duet, but the main choreography stays. A grand approach, a pass, a return, and very slowly, a merging. How does a night feel while this happens? Calm. Think of a long tide rising. Each century, each 1,000 years, Andromeda swells by a whisper of a degree. The stars around you keep their own seasonal rhythm. Meteors still scratch quick silver lines. The moon, if you have one, still climbs and wanes. But above all of it, a new thing begins to occupy more of the canvas. People of that time, if there are people, if there is anyone who looks up with curiosity in their chest, will know stories about it. They will have words for the pale ocean in the north. They will wait for winter, or for summer, to see it most vividly. They will whisper that you can see the arms now. They will point to the central bulge, like a lantern lit above one more hidden city. Behind that poetry, the physics keeps its pace. The dark matter halos interpenetrate first, like two atmospheres blending. Within them, the stars feel a new gravitational field. Orbits shift. The sun, circling the Milky Way every 200 million years or so, will feel a tug that deflects its path, perhaps lofting it farther from the center over time. The disk of the Milky Way will begin to warp more dramatically. Gas clouds at the edges will be plucked into threads and filaments that the night might eventually show as pale streaks, much as we see tidal tails in merging galaxies across the universe today. And still, at this early stage, it is all potential. It is a presence more than an event. The night is fuller, but not unrecognizable. You can still trace the way home by the bright patterns you learned as a child. And yet, in the next movement, the sky acquires a drama of scale and delicacy. Two cities of stars will pass close enough to pull each other into luminous ribbons. You may be able to walk outside and see arcs that look like spilled milk poured by a giant hand. We'll go there in the next breath. Now we arrive at the long, slow crest of the wave, the first close pass. The timing is patient roughly 4 billion years from now, according to the best simulations. By then, Andromeda will dominate a large slice of the sky. Its disk might span several times the width of the full moon, even tens of degrees, so that it's no longer an object, but a region, like weather. The Milky Way's own band will start to look braided, with layers like strands of hair half loosened from their plate. This is the moment when gravity weaves. Picture two disks crossing paths, not edge-on like blades, but more like two vicinities of leaves gliding over a pond and pulling each other's surfaces into wakes. The stars remain, for the most part, insulated by space. But the gas, the dust, the long, ghostly outskirts, these are malleable. When Andromeda swings by, its gravity tugs on the Milky Way's outer arms. These arms respond with courtesies and excess. They stretch into tidal tails, long curved filaments that loop out into space and back, like chalk marks made by a hand with a very wide arc. From the ground, under a truly dark sky and very patient eyes, this would translate into faint, new structures arcing away from the main band of the Milky Way ribbons that weren't there in the memory of earlier ancestors. At the same time, gas clouds within both galaxies will be pressed by these tides and by the passing shocks. Compression leads to star formation. A slow hiss of starbirth becomes a long, gentle rainfall. Whole clusters ignite. There will be regions vast, yet still mere dots to the naked eye, that shine with the light of many new blue stars. In photographs, these will look like jewel-toned knots. To the eye, they may give a grain to the light, a fine, peppered texture, as if the sky had roughened with stars. During the first pass, the cores of the galaxies won't merge. Instead, they will slide by, each wrapped in its own cloud of older stars, each trailing streamers. The night might display a striking sight, two bright cores, separated but tied by faint bridges. Think of two lanterns seen through a fog, connected by a gauzy scarf. Across certain seasons and latitudes, those two cores would rise together, glance past one another in slow motion, and set in different quadrants, days and nights, marked by their mutual, patient choreography. This double-core sky may last for millions of years. An eye blink for galaxies, 100,000 lifetimes for a person, a forever in memory. In this era, constellations as we know them will have long since loosened. New shapes take their place, not because the stars care about our outlines, but because our storytelling mind will always connect dots. A future storyteller might trace the curve of a tidal tail and see a mythical bow. Another might make a calendar from the slow widening of the Andromeda lantern. Rituals will gather around the nights when both cores are highest, their glow casting a soft, collective sheen into the dark. It would not be bright as day, not like the moon. But there might be nights when, in very dark places, the bridge of star clouds raises a gentle white weather overhead, enough to leave the landscape feeling thinly washed. While your eyes climb to these features, the cosmic mechanics continue. Between the cores lie supermassive black holes, one at the heart of each galaxy. The Milky Way's is Sagittarius A*, with a mass of about 4 million suns. Andromeda's is larger, perhaps hundreds of millions of solar masses. They will not meet yet. First, they will orbit, stirring stars around them into a fluffier, rounder distribution. Dynamical friction, the process by which moving objects lose energy to the sea of stars and dark matter, will slow the course. Each pass will be closer. The shapes of the galaxies will slowly shed their spiral grace and take on forms more like triaxial ellipsoids rounder, with shells and ripples. If you could float above the plane and look down, you'd see a grand choreography of swirls and streams. From the ground, you'd see the night lose its single river and gain a complicated sea. There is room here for quieter wonders. As star formation increases, so does the number of short-lived, massive stars that end as supernova. Though their individual flashes would still be rare to any one sky gazer once per century or millennium in your region. Of the sky, the overall sense might be that the heavens are more lively. A new bright star might appear now and then, hush the night for weeks, and then fade. Globular clusters, spherical swarms of old stars, might be shifted into new orbits, making lacy halos around the double cores. Dwarf galaxies on the fringes could be tidally shredded, their stars draped into long, faint rivers that future telescopes, and perhaps very fortunate eyes, could trace. After the first pass, the two galaxies sail apart, slowed by their shared drag through the sea of stars. They carry their tails like comets, turning slowly to face each other again. The sky responds by rearranging. The bridges stretch, thin, and some fade. Others fold back toward the cores. That pale weather of starlight changes season by season over geologic time. In this interlude, the visual drama recedes a little, but the orbits are rewritten. The next approach begins, and with it comes a deeper entanglement. The second pass brings the cores closer. The sky now may host nights when the two central bulges almost overlap in our line of sight, their envelopes fusing into a softer, larger glow. The tidal tails will have grown into full arcs that span giant portions of the sky, delicate, curving features, almost transparent, like frost on a window. For ground dwellers with patience and instruments, this is a great age of mapping, of tracing out the new geography of light. When, at last, the cores merge, we will not see fireworks in the literal sense. What arrives is a recentering, a rounding of the galaxy's heart into a bright, dense hub. The two central black holes will spiral inward, radiating gravitational waves as they do. The final coalescence, a titanic event on the scale of spacetime, would make the galaxy ring in a way only instruments can hear. To the eye, this moment is not a flash, but a slow settling. The outer sky remembers the streams, the arcs, the history. But the center becomes one. All of this raises a question, soft and simple. What is the night like when the dance is over? When the great river and the pale guest become one ocean? We'll walk into that new sky the next breath. After the merging comes a long exhale. The galaxy made from two Milkomeda settles into a shape that is less a pinwheel and more a glowing ellipsoid, a roundish city of stars with a dense, luminous center. Spiral arms, those grand highways of starlight, are gone or transformed into faint, shell-like ripples and subtle streams. The Milky Way's river we once knew has dissolved. In its place, the night has a new logic, and it is quietly beautiful. Stand in that far future darkness under a settled sky. The most obvious change is the core, the central bulge that now sits, for many observers, as a sizable brightness. A lantern over the horizon, or for some, nearly overhead. It is bigger than the Milky Way's bulge today, and brighter. It's like moving closer to a campfire on a cold night. The colors change a little, the details sharpen, and the sense of being near something living increases. Around the core, the light thins into a thick halo of stars. The old band is gone, but a soft, rounded glow spans a wide section of the sky, especially near the galaxy's plane. To your eyes, it might look like a broad, faintly luminous dome, not uniform, textured with delicate grain, the grain of countless stars too faint to see alone. If you could peer long enough, you'd find that this halo is not smooth. It carries fossils of the collision, vestiges written in light. Faint arcs like the edges of water rings ripple away from the center shells formed, when streams of stars pile up where their orbits slow. There are long diffused plumes where former dwarf galaxies were stretched and laid bare. Globular clusters orbit in scattered crowns, each a tiny skeptic of time, a swarm of ancient suns. In very dark skies, or with eyes aided by future instruments, You might trace these features like the faint grain in old wood. The interstellar medium, the gas and dust between stars, has been partly used up in the Great Dance. During the merger, compression sparked starbursts that consumed much of the cold gas, leaving less raw material to make new stars. Over time, star formation slows. The galaxy's light reddens slightly as the young blue stars die, and the longer-lived orange and red dwarfs take over. This, too, changes the night. Instead of rich lanes of dark dust set against a mottled Milky Way band, you have a clearer, cleaner sky near the galactic halo. Dust lanes still exist, but the grand contrast is gentler. You might notice fewer luminous nebulae, fewer bright, sprawling nurseries. The sky, in its maturity, has the deep beauty of a face that has laughed many times and now rests. For many worlds within Milkomeda, the sun's fate will be long past. Our own star will have swelled into a red giant near the time of the merger's climax, and will have shed its outer layers, leaving behind a white dwarf and ember cooling over trillions of years. Travelers, dreamers, and descendants will likely live around quieter stars' small red dwarfs that tick patiently for hundreds of billions of years. From those worlds, the Milkomeda sky will still be magnificent, but in a different key, lower, steadier, a chorus of long-lived, redder light. Look out beyond the halo. What of other galaxies? In the deep future, the accelerated expansion of the universe will push distant galaxies away faster and faster. The local group is bound together by gravity. It becomes an island universe. But beyond this island, the coast recedes forever. In tens of billions of years, most galaxies outside our local cluster will fade from view, their light stretched by expansion until it slips beyond detectability. The cosmic microwave background, the afterglow of the Big Bang, will sink to wavelengths too long to measure with any practical instrument, an echo falling into silence. The night, outward, becomes emptier. Inward, it remains full. The effect on the night's feeling is strangely intimate. The sky loses the pricks of far-flung galaxies. It gains the profound immediacy of its own depth. The Milkomeda halo is a cathedral roof. Its center is a sanctuary lamp. The faint ripples of past mergers are own, and those of absorbed dwarfs are like the carvings on the pillars. If you look long enough, you might see the occasional sparkle of a nova or a supernova, brief candles flaring and fading on the ledges. You might learn to navigate not by the constellations of old, but by the contours of this luminous dome. The place where the halo densest meets the horizon at a particular season, the slight asymmetry left by a tidal tail's trailing light, the paths of the brightest long-lived red giants that mark your planet's version of north and south. Milkomeda will likely have a central black hole more massive than either of its parents, the result of their merging and subsequent feasts on gas and stars. Now and then, as a cloud wanders too close, or a small star strays inward, the fusion of matter at the edge of the black hole may launch a flare. For a brief time, the galactic center could shine more fiercely, lighting the halo's inner curve, a softening twilight in the eternal night. Then it dims, and the equilibrium returns. We can compare this future sky to the skies of other galaxies we see today. Merging spirals like the antennae show us what tidal tails can write. Giant ellipticals like M87 hint at what a settled remnant can be, with their round halos and jet-lit cores. Shell galaxies like NGC 3923 share their fossil ripples. A universe is full of elders and ancestors whose portraits we can study as guides. They tell us the night after a merger is not an erasure. It is a reassembly. It is a different, quieter kind of complexity. In this phase, humanity, whatever that word comes to mean, may have learned to call stars by new names, to build instruments that draw delicate light without harming the night, to live with skies as companions. There will be new pilgrimages, not to the dark, to see the Milky Way's dust lanes, but to high plateaus and clear nights, where the Milkomeda halo is at its most luminous and where the core's glow reflects quietly from snow or sand. And the gentle cliff now, as ages lengthen, as star formation eases and red dwarfs become the long-hearted keepers of flame, the night will slow even more. What does it mean to hold wonder in a universe that is cooling and stretching? What does it feel like to sit under a sky that holds its breath for eons? In the last part, we'll return to the human rhythm, to this moment of looking up and let that future sky fold into our present one.
Come back softly to where we are, to a world where Andromeda is still just a smudge and the Milky Way is still a band. Let the long future we've walked through settle in you like a slow tide. The story of the Milky Way and Andromeda is cosmic and beyond our lifetimes. Beyond our civilizations, beyond the endurance of our mountains. Yet it is also a story about the act of Luckingaboo standing beneath a sky and feeling both small and held. What will the night sky look like after the collision? It will be changed and beautiful. Before the merge, the sky fills with arcs and bridges, with two bright cores sharing the darkness like neighboring hearths. During the embrace, starbirth peppered across the heavens gives texture and occasional flashes of wonder. Afterward, the sky softens into a luminous dome, more rounded than banded, with a bright, steady core like an ember and the faint fingerprints of the dance preserved in shells and streams. The far galaxies thin away into silence. The local galaxy becomes our island and our lantern. We can understand why with the quiet bones of physics. Gravity pulls in slow poetry. Dark matter sets the stage. Gas responds to pressure with starbirth, and stars themselves with their lifespans of millions. Billions, trillions of years compose the light of the night. Orbits change. Energy is traded back and forth like breath. Supermassive black holes spiral toward each other in a gravitational waltz, and when they merge, the whole galaxy relaxes into a new posture. To us, who live in heartbeats and seasons, this is too slow to see directly. But we can imagine it faithfully. We can model it. And we can let that imagined sky soothe us. There is comfort in the thought that even when everything changes, it finds new forms of beauty. The Milky Way's river gives way to Milkomeda's sea. We lose the constellations we know. We gain ripples that remember the past. The night becomes rounder, calmer, more patient. Its brightness is never harsh, but always present as if the universe had placed a lamp at the far end of a room and asked us to sit with it. The collision does not bring violence to our doorstep in the way our stories sometimes fear. Stars will not smash together in a raining fire. Worlds will keep their nights. The changes are grand yet gentle. And if watchers exist in that future, they may tell bedtime stories of the ancient age when the sky had two hearts. And the elders will say, there was a bridge of light once, and on cold nights you could see it, and it felt like a promise. For us in this now, the promise is this: we are part of a living cosmos. The atoms in our bones were built in stars like those that will someday make the Milkomeda halo. We carry within us the same potential for long patience. When you look up tonight and trace that dim patch of Andromeda, know that you are looking at family. Know that two great homes are slowly walking toward each other, and that their meeting will leave behind not ruin, but a new city of stars. It is possible, of course, that no human eyes will see that city. Perhaps life will have moved on in form or in place. Perhaps our descendants will live around gentle red suns, under skies where the dome is soft and quiet. Maybe they will have memories of Earth as we now have memories of childhood summers, distant, warm, and the source of who we are. They will inherit the night we have imagined, and they may find in it the same feeling we do, that blend of awe and ease that comes when we meet something vast and settle, anyway, comfortably inside it. Between now and then, let the night we still have be a practice. Go out when it's clear. Find the Milky Way's faint milk across the dark, seek Andromeda's small cloud, and stretch your imagination across the light years between. Remember that you are seeing a moving moment in a longer dance. Let your breath follow the universe's pace, slow and down to earth. Feel that you live in a story written by gravity and time, and that somehow it's also a lullaby. Thank you for joining this gentle journey. If the calm of these cosmic nights speaks to you, and if you'd like to keep wandering together through oceans of light across quiet, curious questions, you're welcome to subscribe. No rush. We'll be here watching the sky change, one soft breath at a time.